Right, so discrete random variable question again. So we know a couple of things. That one plus that one plus that one plus that one must make 1. And we know we're given that our expectation is 0.8, find the value of C. So we know to find the expectation, all of these times together and then added up should equal 0.8. Now if you couldn't, if you're a bit put off by the fact you've got 3 unknowns, still just go through the process. Minus 2 times A plus 0 times B plus 2 times A plus 4 times C, and we are told that that is equal to 0.8. So 0 times B means that disappears. 2A and 2A cancel each other out. You're left with 4C equals 0.8. C equals 0.2. Okay, they're not the devil, okay? For 2 marks, it should be fairly straightforward, even if you're put off by these letters. Next bit, expectation of x squared is equal to 5, find A and B. So that's this number squared times that. So minus 2 squared times A plus 0 squared times B plus 2 squared times A again plus 4 squared. A couple of people missed off the squared on the 4. They just got 2 times C, but we now know what C is. Equals, what was it? 5. So we get 4A there and another 4A there, gives us 8A plus 32 equals 5. A pops out to be 0.225. Okay, so that's only the A bit we've got. We need to find B. We still haven't used this fact that we know that all of those probabilities in that table must add up to make 1. So we know what A is, we know what C is, so we can number crunch B and get it out as 0.35. Okay, find the variance. So you've done all the hard work for this. They've actually set you up. The variance, remember, equals expectation of x squared minus the expectation of x all squared. Use as many brackets as you want so you remember that. So expectation of x was 5, expectation of x squared is 0.8 squared, take them away, 4.36. D. We've got a new variable come in, y equals so many lots of x. Well, that's fine, expectation of y, we know that, expectation of y, well, let's translate it back to x is 5 minus 3 lots of x, and I know that using my laws of what I can do with these things, that this is 5 minus 3 lots of the expectation of x, which was 0.8 right at the beginning. So stick in 0.8, 5 minus 3 times 0.8, and you get out 2.6. Similar kind of rule for variance, although variance is a bit easier, harder to remember, a little bit easier to work out. Equals the variance of 5 minus 3 lots of x. The 5 doesn't make any difference because if you just add 5 to all your bits of data, it doesn't make it more spread out, everything just shifts. If you times all your bits of data by minus 3, they are going to be a bit spread out and they're all just going to become negative. So the only thing we need to worry about is we take the 3 and we square it and we times the variance by 9. So just a couple of little rules you should remember. So 9 times the 4.36 equals 39.24. Right, F. Obviously that y is greater than or equal to 0. So what you could do is you could just go and work out all your y values that go over these x values if you wanted. Or you could just say, right, instead of y being bigger than 0, I want 5 minus 3x to be bigger than or equal to 0. 5 is bigger than 3x. 5 over 3 is bigger than x. So I want x to be less than 1 1/3. So x could be either of these two. So that would be adding together 0.225 plus 0.35. Your A and your B from earlier gives you 0.575. An alternative way of doing that one, of question F, is actually going up to these values up here and changing them for y's for each one. So doing 5 minus 3 lots of x for each one. If you did 5 minus 3 lots of x there, that would give you 11. 5 minus 3 lots of x here would give you 5. 5 minus 3 lots of here, minus 1. 5 minus 3 lots of 4, minus 7. What's the probability that y is greater than 0? If it's greater than 0, these two are negative, so it can't be those. Greater than 0 means I want this one or I want this one. Greater than 0 then is just the same as we had before, 0.255 plus 0.35. 0.575. Magic. Where'd you get your marks? 2 here. 1 for your method, 1 for your answer. Same kind of thing on the next bit. Bit more method in here. This one. 1 method, 1 answer. Another method, another answer. Knowing the formula here, working it out correctly, 1 there. You don't really get any method marks on that one, just let you know that was the rule. 1 method mark here, 1 answer mark, and a little bit of method mark, basically that either to see this and then these two added together. That was 1 mark each. Well, 2 marks here, 1 for that. Basically you get 4 marks in total for finishing this one off. But seriously, you could have had your method in lots of different ways, but not too shabby.